So the purpose of today's lesson is going to be, we're going to be looking at the most basic shape that you have in geometry. And we've looked at lines, all right, we looked at two lines. And now we're going to look at when you have three lines that are all connected, those make a triangle, which is the most basic, the most simple shape in geometry. And there are a lot of things that we can talk about with triangles. So the first thing we're going to look at is all right, what does or what criteria or maybe specifications does it take to say that two triangles are equal to each other? And why might this be useful? You might use this when you're building something. A lot of builders, houses, they have triangular support beams and things like that. And we may want all our support beams to be equal to one another. So there are some four basic principles that allow us to say that triangles are congruent to one another. We're going to go through all four of those. Okay, the first is what's called the side-side-side congruence postulate, or just the congruence rule, congruence pattern. And this one is kind of self-explanatory. If three sides of one triangle are congruent or equal to three sides of another triangle, then those two triangles have got to be the same exact size and shape. So if this side length is equal to this side length with the one tick mark, maybe that side length is 8 units, then this one's going to be 8 units. If the two tick marks is 10 and this is 10, and maybe the 3 tick marks is something a little smaller, let's say 6. All right. If I laid this triangle, it would lay exactly on top of it. And that's why we can say that these two are congruent. The reason is from side, side, side. All right. These sides all match to one another. And so if I'm kind of going through this, I see that this side 8 matches with this side 8 over here. This side 10 matches with this side 10, and this side 6 matches with this side 6. So we say that this is congruent by side, side, side. Okay, the next type, it's called Sideangleside congruence postulate. So if two sides and the included angle, or the angle that's in between the two congruent sides, it says if two sides and the included angle of one triangle are congruent to two sides and the included angle of the second triangle, then the two triangles are congruent to each other. So if you see here, we have the tick mark, that's my side, we have my angle, and we have a side. We have a side, an angle, and a side. And the angle here is included. It's in between the two sides. All right. That is enough to say that my two triangles are congruent to each other. Again, this triangle would fit exactly on top of that triangle. Okay, so that's our second type, side angle side. Okay, the third type that we're going to talk about is called Angleside angle congruence postulate. And it says that if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then they're equal, or they're congruent to each other. So here you see that this is 45 degrees. Obviously that matches with another angle that is 45 degrees. This side is included. All right, so we have an angle that matches with this angle. We have a side that matches with this side. And then obviously 35 matches with this 35. So, excuse me, that's not a side, that's another angle and another angle. And so here these are congruent by ASA, or angle side angle congruence. So these two triangles are also going to be equal to one another. Okay, the fourth one that we're going to look at is angle side congruence postulate. If two angles and the non-included side of one triangle are congruent to two angles and the corresponding non-included side of a second triangle, then they're equal to each other. So you can see here, this angle matches with this angle matches with this angle, and then the side that we have is not included. All right, you have AAS and AAS. So these are congruent by angle side. Okay, and this is actually, these are the main four. You have SSS, SAS, ASA, and AAS. there's a fifth type that you could also have. I know we said we're going to talk about 4 types, but we're going to add in this fifth type just to see what it looks like. So this is called hypotenuse leg congruence theorem. If the hypotenuse and the leg of a right triangle are congruent to the hypotenuse and the leg of another right triangle, then the 2 triangles are congruent to each other. So here you have your hypotenuse, all right, which is a side. You have your hypotenuse, which is a side, all right, and you have a leg and a leg, okay? And so you have a hypotenuse congruent to the other hypotenuse and a leg congruent to the other leg. Then this leg has to be the same as well. So you end up having kind of like a side, side, side. But all you really need to know is just those 2 sides. You don't need the third side in a right triangle. This is enough to say that they are congruent by hypotenuse leg. Okay, so let's go and look at just some examples of, we're going to say which type. So you have, I'm going to make it easy. I'm going to put our types up here, SAS. You have ASA. We have AAS. And we have HL. All right. So which type of triangle congruence, if any, we may have one that's not congruent to each other, could we use to say that these triangles are congruent to each other? All right, so the first one, let's look at some of the angle markings that we have, or the side markings that we have. We have that right angle, that means that this is a right angle as well. All right, so you know you have an angle here and an angle here. Okay, we also have that they have a matching side. So they have a side and a side. Okay, and then there is not a third piece of information. However, it is kind of obvious that this side right here in this triangle, this piece is got to be the same in this triangle as well. All right, and so that means that this side, the squiggly side, is got to be equal to itself. So what we're allowed to do is say that, hey, that side is shared. All right, they're kind of butted up against one another, so they have a shared side, and so you have a side there and a side there. So this could either be Sideangleside congruence, all right, or nothing else. So it has to be Sideangleside congruence. And you may say, well, coach, isn't this a right triangle? And I have a right triangle here. Yes, you do, but I would not be able to use hypotenuse leg, because in hypotenuse leg you have to have the hypotenuse in both of your triangles. And in this one, all we have is 2 legs. All right, I have a leg here and a leg here. So hypotenuse leg would not work for this one. It has to be Sideangleside. Okay, let's look at number 2 right here. This set of triangles. All right, and so we have this side here matches with this side here. We have the 2 tick marks is another side that matches with this other side. Okay, so we need one more piece of information. All right, we need 3 things. 1, 2, 3. We need 3 things for each of the triangles, unless it's HL. All right, so I've got to come up with a third piece of information. Well, just like we were able to add in this third side, all right, by saying that they were, butt to butt, they were right up next to each other, okay, we are able to add in some information here. The problem is they don't have any sides that are shared. It's not like the triangle is like that in relation to our other triangles. So the only thing that we have is an angle that's up next to each other. And so kind of if we thought about this angle here, K, we know that these are vertical angles. So I know that this angle here, I'm going to add this in orange, is equal to this angle. Okay, because of vertical angles, the vertical angles theorem that we've talked about before. And so if you see that, now we have side angle side and side angle side. So these are congruent by side angle side congruence. Okay, let's look at number 3. Number 3 is this set of triangles here. So you see you have an angle that matches with this angle. You also have an angle over here that matches with this angle. All right, and they have a side that is shared, all right, in between them. Okay, this kind of, you could say the squiggly side is matching in both triangles, and so this side matches with the side in the other triangle. And so I think you can see that this is going to be angle side angle. So these are congruent by ASA, or angle side angle. Okay, and then our last type that we have, we're noticing that this side is congruent to this side in the other triangle. The 2 tick marks means this side is congruent to this side. And then again, they share a common side. All right, they're backed up against one another. And so this side here is equal to this side in the other triangle. And so you see you have side, side, side. So this set of triangles is congruent by side, side, side congruence.